Okay, so we're now looking at obtaining equations for parallel and perpendicular lines. This one's a little bit tricky and we need to mix a bunch of skills together. So here we go. Find an equation for the line that is parallel to x plus 3y equals 6. So this is the line that we're given, but we want to make a new line, an equation for a new line that's parallel to that one, so it'll have the same slope. So we need to figure out what the slope is for that. But that also contains this point 3, -2. Okay, so that's what I wrote in the steps here. Step 1, find the slope for line 1, the given line, because we need to use that. Then write an equation of a line using that slope and the given point for line 2, which is up here. So we need to use our point slope form. That would be step 3, or part of step 2 actually, would be use point slope form. Okay, so I'm going to write that down here. We have y minus y sub 1. This is something to commit to memory, equals m times x minus x sub 1. So when you're taking a quiz or a test, if you don't remember it, you obviously aren't necessarily in a testing situation, proctored, but you should still have everything ready with you as if you were. Like, just have a list of your formulas and things like that, or memorize them, because otherwise you won't have time to finish stuff and you'll be hunting around. While you're taking a quiz or test, it's not the time to learn it for the first time. So here we want to now plug into this. We want to plug in our values. So this is x sub 1, y sub 1. And we've got to figure out our slope. So let's do that. I'm going to pull this up here and figure out what m is. Okay. So we would have 3y equals -x plus 6, and then divide everything by 3. And we get y equals -1/3 x plus 2. What we only care about is the slope here. So we're going to take that -1/3 and we're going to put it in for m down here. So let's go ahead and plug our stuff in. Okay, so I took the -2, pop that in. The y just stays as is. I took the slope that I found and put that here. When I took the 3, that's x sub 1, and put it there. Now, this should look very familiar, although it's relatively new for you, but go ahead and, clean this up. You want to solve out for y. And we can have our equation of a line. So I'll leave that for you guys to do. So try that and then check your answer. And so I just distribute and then subtract 2. So I have y equals -1/3 x minus 1 is parallel to x plus 3y equals 6. That's our original line that we had to figure out slope from. And the question also says graph to verify your answer. So go ahead and do that. You can do a table chart, like intercept method might work really nicely for this line, the x plus 3y equals 6. The y equals -1/3 x minus 1. That really works well using slope intercept graphing. So I'm going to pause, give you a chance to do that, and then I will go through it really quickly. Okay, so for this line that we were first given was x plus 3y equals 6. So I just made a little t-chart, plugged in 0 for x, and then I get 3 times y equals 6, which y would be 2. So I'm going to go ahead and plot that. Then I plug in 0 for y here, and I would get x equals 6. So that works out really nicely. And then just jot that down, connect the dots. Okay. This is just a verification, so we don't necessarily need to plot the label up our plotted points and stuff. The other one is over here. I'm going to graph the second line that we found, negative 1/3 x minus 1. So I would start with minus 1 as my y-intercept. And then I'm going to go down 1/3. So this is really good practice for you. Down 1/3. Kind of running out of room there a little. So I could do the exact opposite. Up 1/3. Connect those. And in a perfect world, those would be parallel and never meet. So we can verify our answer. For the next problem, we have example 3.22. Find an equation for the line that is perpendicular to the line 3x minus 2y equals 6 and contains the point 3, -1. Graph the lines to verify your answer. So this one's a little trickier because pay attention to that perpendicular. So I'm going to make sure you get the slope correct with this. So first thing is, get your slope. So it's not going to be the same exact slope as this. We need to get the slope that is perpendicular, right? So we need the negative reciprocal. But in order to do that, we need to find out this slope. So we're going to rearrange this. So go ahead and pause the video and do that. Okay, so I figured out the slope is 3/2. So I need the slope perpendicular to that 3/2. So then I'm going to just flip it around and make it negative. So it'd be -2/3, similar to what we had before. So we need the negative reciprocal. Just write that there. 2, 3/2. Okay, so that's what this is, our negative reciprocal of our second line. So we're going to say m(2), the line perpendicular. So now, given that slope, and you have a point, okay, we're going to use this point 3, -1 as our x(1), y(1), and then use your point slope form. I'm going to leave that for classwork. So go ahead and pause and write the equation of the line. That's a tricky skill that you need a lot of practice with, so it's really good to try that on your own. But if you're stuck, just return and I'll go through it quickly. Okay, so we have y minus y(1) equals m times x minus x(1). We're going to plug in our values. We get y minus -1 equals -2/3 times x minus x(1) is 3. And here I'm going to add those. So then my next line is y equals -2/3 x plus 2. And then I'm subtracting 1. So I end up with y equals -2/3 x plus 1 as my line that is perpendicular. Then the question also asks you to graph to verify. Again, pause. I'm just going to put the answer up there and have it show when you're done. Okay, so there's the graph right there, and you can see they are, in a perfect world, it would be exactly perpendicular, but freehand, it's not so great. But so we have the last one here of this video. Find the equation of the line passing through -1, -3, and perpendicular to x equals 2. So we have kind of a little oddity here, because if x equals 2, that means I have a table kind of like this, like x is 2, y is 3, x is 2, y is 0. X is always 2 no matter what. So I'm going to have actually a undefined slope, right? So if I went to graph that, we'll just do that really quickly. 1, 2. So x is 2. It's going to be a vertical line right through x equals 2. And that is my first line. So it's kind of just tricky to think like, well, what would be, how do I figure out the negative reciprocal if my slope is undefined? Well, what would be perpendicular to a vertical line would be a horizontal line, and we know the slope of a horizontal line is 0. So we're going to say the slope of the line 2 is 0 for new line, right? Passing through this point. And we also know things about horizontal lines, but we can just go ahead and put in our y equals mx plus b. We have our, or actually we'll use point slope just to be consistent here. Y minus y sub 1 equals m times x minus x sub 1. And we would plug in our value would be -3 for that first one, 0 for the slope there, x minus 1. Okay, but then now when I multiply this out, that's all going to be 0, correct? And this would be +3, so I end up with y equals -3. So my little rule, again, thinking back, it's a good review of vertical and horizontal lines. If x is 0, y is -3. If x is 2, y is -3. If x is 1,000,000, y is -3. So let's extend this one down a little bit more. And then I know that I have a line going through -3. Or y is -3. X is 2 up there, and so that is my answer, and that's my little graph. So I hope you found that helpful, and thanks for watching. Have a great day.